Alright, so first topic are null values that are very useful, but also kind of tricky to use. So when do we use null values? Well, one example is for unknown values that we just haven't recorded. So we saw in the sailors table the example where sailor Dustin just does not have a rating recorded. A value may also be inapplicable. So suppose we have a field for a spouse's name and the person is not married. Or we have a field for a driver's license ID and the person does not have a driver's license. And finally, we may want to not record the value for privacy reasons. Maybe it's someone's phone number, someone's login, so it may be perfectly applicable, it may even be known, but we just don't choose not to enter it. We also saw in the Mondial database many examples of null values. So having null values gives rise to a whole set of new issues. One is checking to see whether a value is in fact null. So we'll see that we need special keywords just to say that, and we'll see why in a bit. We have to talk about evaluating expressions when you have null values. So for example, if you have a null rating and I ask you, is that null rating greater than 8? Is that comparison true or false? And it gets even more complicated when these comparisons can involve Boolean connectives. So for example, rating greater than 8 and age equals 18. So should that be true or false if the rating is null? And finally, the key question is ultimately how this affects our queries. So if I have a query, say with a where clause where rating is greater than 8 and rating value is null, should I then return the tuple for which the rating value is null or not? So the first thing to note is that although null in many ways is like a constant, for example, it's something that we can enter in a cell in a database, it really is fundamentally different from things like green or the number 3. Okay. And in particular, we have special rules for null values. Basically, if you try to do any sort of operation on null, you get null back. So if you say, for example, 3 plus 4 plus null, that would give you null. The answer would be null. And when you try to do a comparison with null values, you get a new truth value called unknown. So in the example I gave, if the rating is null and you say, is rating greater than 8, so is null greater than 8, that's neither true nor false, but that gets treated as unknown in SQL. And the key thing to remember is that when you have a query, it returns only tuples where the where clause comes out true. So of course it doesn't return tuples where the where clause comes out false, but it's also the case that if the where clause comes out unknown, the tuples aren't returned. So if I say, for example, select star from all sailors where rating is greater than 8, if the rating is null for a sailor, that sailor will not be returned. So let's see, maybe then someone can have a little demo with that if it's not clear. So now we have to think about the meaning of Boolean connectives with unknown truth values. This is in fact a traditional topic in logic called three-valued logic. It's been discussed by logicians since at least the 1920s. And I'll give you some of the rules that SQL uses for handling unknown truth values, and then we can discuss why they make sense, and I'll give you a couple of ways to remember why they, a couple of ways to remember how they work. So looking at the bottom here, let's look at the rules first of all. True and unknown evaluates to unknown. Okay. False and unknown evaluates to false. Okay. So if I have a condition where the first condition is false, the second is unknown, and I put them together in a conjunction, I get false. If I have false or unknown, I get unknown, and not unknown is unknown. So let's think about why those make sense. So one way to think about them, at least some of these, is in terms of lazy valuation. So let's look at this one, for example. False and unknown. Well, if I have a condition that's false and I say something that's false and something else, the result is guaranteed to be false. Right? So if I say the age is greater than 60 and the rating is 8, and you tell me that the age is in fact 50, well then I already know that the comparison is going to come out false regardless of the other value. In the other cases, you can see that that lazy valuation strategy does in fact not work, right? So for example, for the first clause here, true and unknown, that could come out false, right? So if the second condition is turns out to be false, then the whole conjunction is false. So basically, one way to think of what SQL does is it applies this lazy valuation strategy. So if it has enough information to conclude for certain what the outcome of the comparison is, like in the second case with false and unknown, then it returns what it can conclude, false, for instance. And if it doesn't have enough information to be certain about what the outcome is, it returns unknown. So what do you think you would get if you had true or unknown? Let me see if I can write that. True or, let's just call this UK. Okay, so ask Zensong for the answer, and this might be a cause for discussion. So this logic is known as Kleene three-valued logic, after the great American logician Stephen Kleene. One way to remember it that you might find easier than just memorizing the rules is if you think of true as being corresponding to 1, false corresponding to 0, then you can think of unknown as corresponding to a half. So that makes sense, right? Unknown is like between true and false. And so now you can generalize the usual rules. So if you think about ones and zeros, and takes the max, right? So for example, 1 and, sorry, I should have said and takes the minimum. So for example, 1 and 0 gives you 0. Or takes the maximum. So for example, 1 or 0 gives you 1. And not gives you 1 minus your truth value. So not 1 is 1 minus 1, which is 0. Okay, so that means not true evaluates as false. Okay, so if we apply that to our various cases down here, here's what we get. Let's say, let me get rid of this first. Let's say we're looking at true or unknown again. So this one. So true is 1. Unknown is a half. I need to center pen here. 1 over 2. And so and says that we take the max, the min. I made that mistake again. So the min is a half, right? 1 min and a half. The minimum is a half. So we get back the answer a half as the minimum. And let's see where else. Let's do maybe one more example here at the bottom. Let's say if we're talking about negation here, we have 1 minus a half, so that's equal to a half. Okay, so I hope that makes sense. Now let's go see how we can apply that. So let's think about this query. Select everything from sailors where the rating is less than 5 or the rating is greater than or equal to 5. So before today's lecture, you might have thought, oh, that's going to give me all the sailors. But in fact, that's not necessarily true, because If you have a sailor with a null value, let's see how that evaluates. So rating less than 5 is a comparison. So null less than 5 is unknown. Okay. Rating greater than equal to 5 is also unknown, because we're comparing a null value. And then when we do unknown or unknown, if you think of lazy valuation, well, they could both be false. Or if you think of our half rule, that's the max of a half and a half, which is a half. So this or also evaluates to unknown. And so that means that for a sailor whose rating value is null, the where clause evaluates to unknown. And SQL does not return a sailor who whose where clause evaluates to unknown. It returns only the tuples that whose where clause evaluates to true. Okay, so you can check that for yourself by running the query in the sailors table. Okay, but that is a tricky thing to watch out for. This is easy to screw up in queries if you're not thinking about null values. You may think something like, oh, if it's greater than 5 or less than equal to 5, it has to be selected, but it actually doesn't.